So, we were discussing about ice cream, right. Now, in this class, in earlier of course, we had discussed ice cream. Now, we will discuss about the ice cream lollies also, right. We have discussed about the cups, then party packs, then gallon packs, different forms which are available, right, and how they are manufactured and how, what is the process, etc. Everything we have discussed. Now, in this dairy and food process and products technology, today's lecture 55, where we will discuss ice cream lollies, right. But before that, perhaps so far I remember, we had told you about horizontal ice cream freezer, right. Generally, unless there is a constraint of space, if space is not the constraint, then people do prefer horizontal freezer. But in many cases, there could be the space problem. So, horizontal means say 1.5 meter ice cream freezer along with its accessories all put together, maybe 2 meters, and people working, etc. everything will take another. So, 3 square meter area you may need for one ice cream freezer to be handled with the product. So, if that is too costly for the place where your industry is, then the problem comes, and that is why another mode, that is the vertical freezers, are also developed. And in both these horizontal and vertical, nowadays in our country, alpha level, in earlier APB they were used to perhaps the only producer, but nowadays it is now means long back, it is not today. Long back alpha level and many others have come up with ice cream freezers, and both horizontal as well as vertical are available, right. So, then let us look into the vertical also a little. So, this is a typical vertical ice cream freezer, and this is taken from alpha level, right. And you see from this a cut size has been shown here, right, from where otherwise from outside you will not understand anything, right. The horizontal one we had shown you the sectional view, but this is a vertical with a cut, right. So, what happens, you see your product inlet is this one. So, this is the product inlet through which product is going in, right. Then there is floating O-ring there, these are all supporting. Then these are the blades, right, these are the blades, ice cream blade, that scraper blade. So, that scraper blade is here. Then this is the heat transfer wall. So, heat transfer wall is this, through which the refrigerant is transferring the load. Then there is a rotor shaft, this is the rotor shaft. So, rotor shaft will rotate your the entire assembly. Then this is the insulation. So, insulation that comes through this black wala is the insulation. Then media channel, that is through which it is moving, that is the channel, then the media that is by which you are cooling goes through this, right. And if you look at this is the vertical view or front view, and if you see the top view, it looks like this, right. So, blade, rotor, and heating or cooling medium, and then product and the heat transfer cylinder, all these are there. Okay. And this media, that is heating or cooling media, that comes out through this, and again it is subjected to, if it is compressor, condenser, expansion device, all put together, they are associated with this. That is why there is a cut figure down below. These things do contain, and that is not visible, and your mounting connect, this mounting connector here, okay, how they are being connected, and this is the hydraulic drive by which your product is going out, right. And this product, when it is going out, before that you can incorporate your nuts and fruits, or whatever you like, those things are possible. But the thing is, which is of interest, is that this length, right, that is the Frizzle length, and if you look into the horizontal one, I would like to show you that also, that vis-a-vis this length, that this is the Frizzle length, say it is L vertical, and you see that from the geometry it appears, that this one is the horizontal, right, and the horizontal length is this LH, right. So, this LH is much less than, for the same capacity, we said generally 300 to 700 liters per hour, that is available commercially, right. If this is true, then this LH is less than LV, the reverse, this LH is much less than LV, yes, this is much less than LV for the given capacity, say 300 liters per hour. In that case, this LV is much bigger than LH, right. So, that is what one thing to be kept in mind. Another thing, which is why it is required, because here your thing is being pumped and going like this. So, all the time it is also acting against the gravity, right. Generally, this product would have a tendency, when going up, gravity will pull it down, right. So, the inlet was in earlier case also 4 degrees centigrade, and the exit was at -5 degrees centigrade. If you remember that inlet was like this and exit was like that, right. So, the retention time in this has to be such that 4 degree to -5 degree, this conversion, because this is a continuous. So, this conversion has to take place according to the height or according to the Frizzle length, right. If this is the Frizzle length, then according to that, this conversion of 4 degree to -5 degree where incorporation of this is the product inlet along with the same it was a dual pump there. Here also it can be a dual pump and product will go, air also will go. So, both will go together and they will go pass through this, and this is the scraper blade, right. So, these scraper blades where you remember what I said, that if this is the wall, right, if ice cream here is getting frozen, ice cream mix here at 4° and here it got frozen because your outside is -30 or -40 depending on whatever you have chosen, the pressure and the refrigerant, right. So, and this depends on your inlet pressure of the refrigerant and the exit pressure, that is called discharge pressure and the suction pressure, right. So, discharge and suction pressure, that will dictate what temperature it will be liquid and at how much you will get in terms of enthalpy, right. So, how much delta H you will get, that will be dependent on how you are keeping it, how at what pressure of inlet and exit of the refrigerant you are keeping, right. Then this and we also said that the refrigerant is getting boiled off, right. This is called boil off boil off, okay, boil off heat transfer. So, what is happening, that the moment this liquid came to this, it gets frozen and these scraper blades, when they are rotating like this scraper blade is scraping off and then it is mixing with rest of the thing. So, +4 that became say -5 or even lower, and this +4 when interior they went, there will be a mixing between this +4 and -5 and a resultant temperature will come. So, like that the temperature of the ice cream is gradually decreasing and all the time this surface is getting some quantity of ice cream frozen and then it is getting scraped off, right. So, that is possible, that is why and how this +4 is coming at -5 and some quantity of the ice cream is getting frozen, right. And one more thing which we should also tell here is that for the vertical one, this length being higher for the same capacity, the problem which normally is encountered is the people who are working, because it is not that all the people who are working will be tall. So, that becomes a difficulty for the short heighted people to handle to get this output, right. So, it becomes handling problem, nothing else, right. As far as heat transfer, as far as product quality, these things are concerned, there is no such deviation or there is no such discrepancy between vertical and horizontal. But this problem of handling, that is that could be one consideration. If the people who are workers are not tall enough, then it becomes difficult for them to handle. Otherwise, as far as you see, that flow radius requirement is not more than 1 meter square, whereas there it was somewhere 2 to 3 meters square. So, that flow radius saving is very high, and where it is a costly place, there it becomes mandatory, right. Of course, I have seen both this vertical as well as horizontal ones in yeah, where I used to work there, all the things were horizontal. I had shown you that earlier the layout, plant layout I had shown, but here in Bengal I have seen that in some of the ice cream manufacturers do have this, though there may not be the space consideration so much, but they do have this vertical. So, I had opportunity to see one with work with horizontal where I was, and the other one is with our students. We had visited number of times and seen it, right, seen it working also. Okay. So, with this the ice cream freezer, let us come over to another, that the lolly preparation, right. So, this is the lolly preparation tank. I do not know how many of you are from the cities or from the villages, and those who are in urban may not be, but those who are in villages, I hope they might have seen that that the stick, lolly sticks, only water, colored water, right, lolly sticks, colored water and sweetened colored water, they are prepared in many villages, right. Typically, I was lucky enough again to see in just by the side of our school it was, and it will not be out of place to mention that when we were also school children of that age, our parents also used to tell. Of course, we did not have money to buy like today's children, they have lot of pocket money, etc., but we did not. However, I have no idea with what I mean thing in mind they used to tell that don't take that lollies from the ice cream, because those lollies are being made from dirty water, ganda pani or nalika pani. So, this ganda pani or nalika pani, that is dirty water, that was one thing imposed on the mind, such that you get afraid and you do not get the desire, though you do not have money, but your friends may have and they may buy and give you. So, to prevent that, this kind of things used to be told. But so far I know and I understand that there is no such, but because why a person will use ganda and nali pani? Yes, he may not have a good source of water, but at least some tap water or some drinking water they should use and they use. So, there is no question of using the ganda or nali pani, right. So, because that is loss for him, because ultimately if the product is giving some bad name, or it is, if it is the consumer is getting affected, then definitely their sale will be affected, right. But we used to see how the things were prepared, right. And so far I remember that there was a pond kind of thing, and to my memory, and that pond kind of thing was around say 10-12 feet in length and 6-7 feet in width, and around 3 to 4 feet height, and it was full of water, full of, that time we did not understand why and what, but it was full of water. But also we saw the inside there are some machines, Now we understand that those machines are nothing but the evaporator, heat exchanger, right. So, heat exchanger is there, and we used to hear the compressor sound. We did not understand that time. Some sound was coming from outside, and that compressor is making that refrigeration, cooling, and all these, right. And of course, since it was by in the I don't say city, but okay, semi city, since it was so, there was no question of using ammonia as the refrigerant. So, freon was used, I suppose now, because it was long back, 30-40 years back. So, I don't remember whether we asked what was that, or we understood what was that. But now I understand that that was definitely freon only, and in our country, though freon has been banned, but not to that extent as it is still being used, right. So, a similar one here we are showing you that ice cream lollies are being made in this kind of, this was one where I used to work, it was there. So, a pond, circular pond like that, right, and you see the height as it is, sorry, height as it is around 3 to 4 feet, right, around 3 to 4 feet, and this diameter can be somewhere around 10 to 12 feet, right, around 10 to 12 feet, and there are some these are called molds. There are some molds in which, if this is the mold, right, if this is the mold, you are putting some color remains same, color does not change. Yeah, color is not changing. However, so there is some ice cream mix is being put here, and up to this it is filled, right, and a stick is also inserted, right. So, in this, on the wall, on this wall, this ice cream, when it is frozen, that will get stick. So, what they do, they put this, say if this is one mold, of course, there is no such individual mold, at least 10, 12 ice cream are there, and things are arranged in such a way that minimum 8 to 10 lollies could be placed in one. So, when it is frozen, this side gets stuck. So, you cannot take out this stick outside. So, what happens? They put this in another, after lifting from this, after lifting from there, they put in a water. This is the water, right. The moment it is put on the water, because this is made of solid, that is metal. So, this heat transfer is very high, and the adjacent to this, the ice of this lolly gets melted, right, or gets loosened. So, that time they make the thing upside down, and during that period the stick comes out, and we get a stick of ice cream lolly like this, right. So, this is, and not only that, I gave only one example. So, if you have this kind of thing, and you might have seen that lollies are with different layers, multi layers. So, this is a single layer of say vanilla, this is another layer of say chocolate, and this is another layer of say another thing, chocolate and pineapple say. So, what they do first, and for that you have to have different molds like this, because first one will correspond to this volume. So, according to this volume, this mold is prepared, right, and first you make this lolly and the stick is there, put it inside and then you get it frozen. So, once this is frozen and then you take out from that water system, right, this water system you loosen it and then take it out, right, then you have this new volume, right, and this one is made in such a way that your this volume minus this volume equal to that one, right, and this of course will go in, and this extra layer will only be adhering up to this, right. So, that layer will be this. So, like this second layer you have put it into this and you got this second layer frozen. Similarly, you have put in this water and took it out, and the third one, this layer is then according to the volume of this and this you are making another one where your ultimately the lolly becomes like that, right. So, this way multi-layer lollies are being also made, but the primary thing which is that you have to keep these lollies inside, and not only that, these lollies inside you have to keep for maybe 2 to 3 hours depending on whether you are making single layer or you are making multiple layers, right. If you are making single layer, time and requirement will be more. If you are taking multiple layers, for each layer you may have to have a less time, and then sum together will be a little bigger than that. The reason being, you are taking it out and then putting it to another mold, then again putting it back, again taking it out, again defrosting, all these will take some time. So, total time requirement may in this case, if it is 2 to 3 hours, in that case it could be 3 to 4 hours. Obviously, that single layer one, the price if it is 10 rupees, say your this multiple layer, that will be 20 rupees. So, in that case this additional time investment is paying you back through the price, and also the customer you will have more, and the consumption also could increase, because you are giving many varieties to the consumer, right. So, here also what we have inside of it, which I cannot show, I did not have that time that much of today's cameras. So, there is your inside there is a heat exchanger. So, that heat exchanger throughout is this tank, and this heat exchanger is being cooled by the refrigerant. Generally this is by freon, right, generally this is by freon, and this refrigerant is making this heat exchanger cold, and in turn this heat exchanger is cooling. Inside there is the water, that water, and this is not a simple water plain, this is called brine solution, right. So, this is a solution, brine means salt solution, but this is not simply sodium chloride. It can be chlorides of many things and many others, because the composition I also did not come to know, because it is very much company secret. If I would have worked for a long period, then obviously I could have come across, but I did not try also, because I did not have that intention to break the norms of the company. So, I did not try to know, but this I know from theory, that number of chlorides, number of many other salts are there, and that is being produced, that is keeping the water solution very cold, and maybe around plus minus 30 degrees centigrade, this water temperature inside is there, right. So, if that is true, then you are keeping your molds inside, and mold is such that in this, if this is the mold and if this is the stick, and if up to this your liquid, right, if this the stick of course goes down, if up to this it is the liquid, then in water this tank, this is such that it is floating just like this. Up to this it is underwater, beyond that is above the water, right. It is just, it is dipping and floating. So, both dipping and floating are together. Dip is only up to the portion where you have this stick lolly, up to that portion this is underwater, and beyond that is not in the water system or brine solution, right, and it is kept for that 2 to 3 hours or like that, and the lollies are being ready, and then after taking out the wrappers and other things are being put and then kept in the cold room. This does not need to go to the hardening. That hardening which we had seen earlier is only done for cups, cones and other which is coming out from the freezer, but lollies are directly prepared and they are cold enough, and this goes into the cold room, and in the cold room things are kept under different I mean that the storage temperature, as we said, is minus 20 or below. So, minus 20 degrees centigrade it is being kept, and you are then supply to the different people, right. So, for like this you are keeping your lollies prepared, right. One thing you should also keep in mind that when you are making lollies, you should be ready with the frozen lolly has to be defrosted to unload, right, from the mold. So, your defrosting system also should be somewhere very close to this, right. That defrosting system also should be somewhere very close to this. Otherwise, if your freezing system is here and you have to move around and then find out the lolly how it is to be dipped, then unnecessarily you will be losing time, which you cannot afford to do. And if it is for multi-layers, then this gives lot of trouble, lot of problem to the workers, right, and which in turn will decrease the throughput or the production rate. So, it should be very close to this, and of course, there this floor, as you are seeing, that floor has also, that is true for any food industry, that the floor is always under all time it is being wiped off, so that there is no residual or there is no dirt or any other things. That is the basic of the basic of any industry about the hygiene. So, hygiene has to be such that you do not have any problem of that water dropping or ice cream mix dropping. So, all the time if there be some people are always there who are all the time cleaning the floor, such that it becomes very clean, as well it is hygienic, right, because hygiene is the primary thing, and these are all frozen materials. So, afterwards you have no scope to heat or disinfected. Disinfection is not possible afterwards. So, that is why the primary thing is the hygiene, and that will minimize the chance of getting contamination, because the mix is very highly susceptible to be infected by the organisms, because it contains all the materials. So, that should be hygienically very good, so that the chance of contamination you remove, right. So, this way lollies are being made, and this is called the brine tank, and brine tank, the brine solution is from the chlorides and many others, chlorides, nitrates, which can one thing which I did not say, that is the eutectic point. Eutectic point. So, the eutectic point of say pure sugar, right, pure sugar which we take, that is C6 C12H22O11, right, the sucrose. So, that is somewhere, if I remember correctly, around -5 degrees centigrade. Sodium chloride has an eutectic point of say -21 degrees centigrade, right. So, like that, when they are making the brine, it is taken in such a way that even at -32 degrees centigrade, the brine solution remains liquid, because liquid has the highest heat transfer. So, heat transfer will be very good, and it will be liquid, and this pond you can keep it is closed, that will minimize the heat loss, right, because once you have loaded it with the ice cream lollies, then for 2 hours to 2 to 3 hours it will be there. So, you can keep it closed, so that the unnecessarily open, the top is not open, and it is being transferring from the top to the water brine, right. So, this way you can minimize the loss and maximize the profit. Okay? Thank you.